Hello guys, in this session let us solve some problems in our common setup, that is especially in our control system designing, right? There are two type of common setups that we are using. One is called common setups, that is control system design. We have two types. One is common setups that we are using in frequency domain. Another one is our controller that we are using in time domain, right? Okay, the things that we have been controlled already. Anyway, we are getting back. Question number 1. The given question is, you are requested to identify the type of the common setter, that is lag common setter. They are given 4 options. Very simple, right? What I will told you, in case of lag common setter, the dominant person is our pole. In case of leading common setter, the dominant setter person is our 0. That things we know, right? So meaning priority first for lag common setter, priority will be given for pole. In lead common setter, priority will be given to 0, right? From the origin. Now, எப்படி ஐடென்டிஃபை பண்ணுவீங்க? Lagging in the sense pole, leading in the sense 0. ஆனா எங்க இருக்கணும்? Nearer to origin. From the origin, nearer I have pole. See there, in common setter we have two people, one is pole, another one is 0, right? Nearer origin, if I have pole, right, in the left half of S plane, first thing, you should keep all your poles and zeros in the left half of S plane, because common setter is a type of stable device that will going to, what I can say, this device will going to compensate the effect of the system, right? So thing is, anyway, the question is lag common setter is what? Priority. For lag common setter, priority will be given to pole. So from the origin, if a person having a pole nearer to the origin, and then if you have 0, then that is called lag common setter. From the origin, okay, this is not a type of common setter and it is not a common setter. Whereas this one, nearer origin, we have a type of 0. Priority will be given to 0. So this is called a lead common setter. This is called lag common setter. So the correct answer for our question is lag common setter. For lag common setter, this is the correct answer. Let us see the next one. Let us see the next one. Actually, the question is, the phase lead compensation is used to do, right? They are given 4 options, right? In option A, given it is rise time is increasing and the maximum peak overshoot is decreasing. Option B, rise time is decreasing and the maximum peak overshoot also decreasing, right? Option C, rise time is decreasing and the maximum peak overshoot is increasing. Option D, rise time increase, maximum peak overshoot also will increase, right? Let us see what shall we do in this case. In case of phase lead compensation, we know, right? Phase lead, that is called lead compensator. Usually what we are trying to do, in the phase lead compensator, priority will be given to you, priority will be given to lead compensator, zeros. In case of phase lead compensator, priority will be given to zeros, and then we are adding additional pole with the system. Yes or no? Yes. And I have been told you, if the priority will be given to 0, then we have been observed what type of changes that we can observe in our system, right? The thing is, whenever we are adding a 0 into the system, what will happen? First one, stability of the system will be improved. First thing is, stability of the system will be improved. That things we have been concluded. Next thing, because of the addition of the poles, right? That is, in case of lead common setter, priority will always be given to, what I can say, zeros, right? Zeros, because of the addition of not poles, zeros. Because of the addition or because of the dominant effect of the 0, transient behavior of the system will be improved a lot. I have been told you, right? So transient behavior of the system will be improved a lot. Transient behavior improving of the meaning time taken by the system to reach the steady state, that is often known as rise time. Your system will take very less amount of time to reach the steady state because transient behavior will be improved. When the moment we are switching on the fan, it will take very less amount of time to reach the steady state. Very quickly we are reaching the steady state, such that rise time of the system is getting decreases. And then what we have been observed, because of the addition of the zeros, damping ratio of the system will be increased in case of secondary system, such that what we have been concluded, maximum peak overshoot. If damping ratio is keep on increasing, then maximum peak overshoot will going to be decreases. Then what we have been observed, because of the addition of the 0, we have been observed many other things, right? I have been concluded the product of rise time into bandwidth will always be equal to constant, such that if rise time will increase, then rise time and bandwidth, from this I can say rise time will be reciprocal to bandwidth. If rise time will decrease, then bandwidth offered by the system will increase. That things have been observed. Similarly, when the moment we are adding the pole in our polar plot, Bode plot, what we have been seeing, if I have a plot like this, because of the addition of the poles, because poles add பண்ணீங்கன்னா நம்ம பார்த்தோம் இல்லையா plot எப்படி இருக்கும் அப்படிங்கிறது we have been observed, right? See there, positive slope will be already some system will be there. and the system கூட நீங்க positive slope add பண்ணீங்க அப்படினா it will be tilted above such that slope is decreasing, right? I said because of the addition of the poles slope will decrease at the same time. From this here we have been concluded many things in our lecture. What we have been concluded, gain crossover frequency will increase, phase crossover frequency will be increased such that phase margin will obtain more and more positive value, gain margin will obtain more and more positive value, that is R will increase such that stability of the system will be improved a lot. These many things that we are observing in case of phase lead compensator, whereas in phase lag compensator this process will be opposite, right? That's just opposite to these things, right? So the conclusion is, for our question the correct answer is what we have to, in case of, because of the phase lead compensator, right? Actually they have given only two parameters. They are talking about rise time and peak time, that is maximum peak overshoot. Rise time will decrease as well as maximum peak overshoot also will decrease. So the correct answer for this question is option B. Let us see the next one. In this question, actually given it is maximum phase lead is what? Actually we have to find out the maximum phase and what I can say correspondent frequency, right? Frequency. Maximum phase lead. Anyway, we are in compensators. In compensators only three devices are there. It might be lag lead or lag lead compensator. Especially whenever we are facing the questions from this area, it might be the question is phase angle frequency, it is only for what I can say lag compensator or lead compensator. The things we have been observed already, right? So the thing is, given question itself it was given phase lead compensator, already we saw some general set, some general definitions for phase lead compensator. See, first thing, the general representation of phase lead compensator, what we have been observed, I hope you all remember, that is tau s plus 1, that is what I kept in the numerator. Denominator was written as alpha times of tau s plus 1. That is the general representation of lag and lead compensators. That things we have been observed already. And then when your phase lead compensator will going to obtain its maximum frequency, that is maximum phase cycle, phase lead compensator maximum phase cycle varumbodhu the corresponding frequency is known as 1 upon what we saw, that is tau into root of alpha. I hope you all remember. Similarly, its corresponding frequency, its maximum frequency also, I have given two formula. Either we can go with the general formula, that is sin inverse, right? I skipped the derivation, just I have written the formula itself, right? Formula only. I hope you all remember. That is sin inverse of 1 minus alpha divided by 1 plus alpha. Yes or no? So this much of things that we are observing from our system always, right? So let us continue from here. Now we have to calculate the value of tau and we have to calculate the value of alpha and we have to substitute the value of alpha here such that we are going to calculate the value of maximum phase cycle, right? So let us see one by one and let us see how to scratch this all things. So the thing is, this is general definition, right? Various system is given here. Just to compare these two things, from this I can say the value of tau should be equal to 0.5 and the value of alpha comma, that is alpha into tau should be equal to 0.05, right? So from this I can say the value of, see that, just to compare tau, here tau is plus 1, that is general system, this is given system. Question will be like that because compensator is generalized. We have seen the general system. I said in control system we are always designing the general systems only. We are not specifically targeting any physical systems like our electrical machines and power systems. In electrical machines and power system, what we are doing, we are specifically targeting the transmission line and we are understanding the property. We are specifically targeting the alternator and the transformer. See how many things we are observing in our power systems. In electrical machines point of view, we have been concluded many things, right, about the alternator. Whereas when I am looking at the same alternator properties in the power system point of view, when it is connected to the infinite grid line, we have been observed many things, right? And that is what we are looking in our power system. That things we have been observing, especially in our stability analysis and fault analysis at all. But in control system, sir, how we are generally matching these things at all? In control system, first what we saw, we are looking for second order system. Second order system, I had given the general response, general system. In first order, we have general system. Type 1, type 2, all are, they are going to be connected to the physical world, but I am generally designing all these things. So this is the general representation of our compensators, like it might be lag compensator or lead compensator, and then we can match this with the physical variables, that is the physical system. Whereas given it is physical system, I know the general system, just I am comparing these two, and I know, right, general system learn how to obtain the maximum frequency, that is frequency in which phase angle will become maximum, and we know already, right? So just I am going with of this given data, that's all. Don't be panic, just always whenever we are looking at the question like that, just compare your physical system with the standard one and compare the data, just substitute, you will get the answer. Just remember these three equations. I am repeating once again, they are very very important. Clear? Okay. Now just I am comparing. Tau should be equal to 0.5, alpha and tau equal to 0.05, such that the value of tau is equal to 0.5. If you substitute, the value of alpha will become 0.05 upon 0.5. See there, it will become 0.1. So I can say the value of alpha is going to be 0.1. What we are going to do? Next, we have to calculate the value of. Anyway, the question is maximum phase lead. Phi is what, right? Phi is what, and then corresponding frequency also you will be tested, right? Let us see. So that is going to be 1 upon first maximum frequency formula. Tau is equal to how much? 0.5. Your questions are very simple, very simple. Under root alpha is how much? 0.1. Just to substitute these two values, you will get 6.324, right? Already I have been solved this one. So you will get 6.324 radian per second. Clear? Frequency. Correspondent phase angle is going to be, just to take this one, replace alpha by 0.1, right? Replace alpha by 0.1. So 1 minus 0.1 will give you 0.9 divided by 1 plus 0.1. 1 plus 0.1 will give you 1.1. Such that, so in this other what we are going to do, just to substitute these two values here, you are going to get sinus of 0.9 divided by 1.1 will give you exactly 55 degree. Of course, I can say exact value is 40, what I can say 54.9 degree, right? Exact answer, because 9 by, that is 54.9 degree, but approximately that should be equal to 55 degree. So the correct answer for this question is option D. Guys, don't forget, let me repeat once again, in control system designing, especially whenever we are solving the problems in compensators and the controllers as well, there are no many things to learn. But in general world, whenever I am adding a pole into the system, what will happen? When I am introducing a zero into the system, then what will happen? That is what we are looking for. In lead compensator, priority will be given to 0. In lag compensator, priority will be given to pole. Just remember that one. And because of that, what will happen? That changes, you have to keep it in your mind. And second thing is, in lead and the lagging compensator, what is the general representation of our system parameter, and then how we are calculating the maximum phase angle and the frequency from these two parameters for the given system. Clear? So these things are all very, very important in your compensators. With this, you can solve all questions. Let us see the next one. Let us see the next one. In this question, here it is. Actually, some general transfer function is given once again. Question is, for lead compensator, what is the value? That is which one satisfies the condition for lead compensator? That is given. Okay, once again, we are in compensators, right? The things that you have to remember in our mind is always priority. Whenever we are giving, whenever we are discussing about lead compensator, priority will be given to 0. Whenever we are discussing about lag compensator, priority will be given to pole, right? But the first thing and second thing, we have to remember the general expression for our compensators, right? Now, what is the general expression that we saw? So, whenever we are looking for control system designing, that is controllers and what I can say compensators. Anyway, in our compensators, the general transfer function can be written as what we are, how we are writing, tau s plus 1 upon alpha times of tau s plus 1. That things we know, right? That is the general representation. Second, what I have been told you, just remember maximum frequency formula, that is 1 upon, that is tau into root of alpha, that is the second one. Third, we have to remember the value of pi. Pi is equal to sin inverse of 1 minus alpha divided by 1 plus alpha. Just to do remember all these three things in a clear way in your mind, right? Anyway, these things are I am not going to use in this question. I know that one, but you have to register these things in your mind. Then only you will be able to crack all type of questions. Anyway, this is our general representation. Same way, such a given system is given to us. Some given system is given to us, and anyway, you can design. You can treat this system as a lead compensator or lag compensator. It will be decided by us only. But let us see what will happen. How can you get it? Given it is some type of system. In the system ஒரு lead compensator நீங்க ஆட் பண்ண வைக்கணும் அப்படினா இதோட கண்டிஷன் எந்த கண்டிஷன் வந்து satisfy பண்ணும் இதோட lead compensator ஆக்ட் ஆனா அப்படினு கேட்டிருக்காங்க, right? So anyway, when I am looking for lead compensator, priority will be given to pole. So pole will be placed nearer to the origin, and then the second priority will be given to pole. Sorry, in case of lead compensator, priority will be given to 0, and then the second priority will be given to pole. Now, when I am talking about lag compensator, in case of lag compensator, priority will be given to pole. That is, dominant pole will fall in place. Dominant pole means it is a type of pole which is always lying nearer to the origin. That things we know, right? So if I consider dominant pole, then that is called a lag compensator. If your dominant is 0, then that is called a lead compensator. Yes or no? Yes. Now see there, in our question, 0 in the sense numerator of the transfer function, pole in the sense denominator of the transfer function. Yes or no? Such that if I find in the 0 value find s by a plus 1 equal to 0, such that the value of s will become minus a. Similarly, if I find the value of pole, s by b plus 1 equal to 0 such that the value of the pole is going to be S is equal to minus B. Now first we should, in case of lead compensator, first we should be, that is we should place our pole, 0, and then we have to place our pole, right? 0 value minus n, that is minus a. To design this system as a lead compensator 1, I have to choose some value. First I know 0 first place pannom, adukapra neenga pole for second place pannikalam, such that see there minus a minus b. If I find the magnitude, if I magnitude find panninga appadina, definitely value of b will become greater than value of a. Are you getting me? Magnitude find panninga. Why? How it is? In case of negative axis 0 1 2 3 4 5 6, but in minus it will become like this. Appa negative neenga ippadi poga negatively your values keep on increasing such that nearer to the origin. For an example, if I have minus 1, the next point will be minus 1.1 minus 2 minus 3 something, but adhu magnitude edukumbodhu magnitude appadina just consider the magnitude, don't consider the signs ada, correct ah? Appo magnitude eduthu pathinga appadina indha point la irukkadoda value, idoda magnitude will be greater than the value of this magnitude, that is in case of lead compensator. Suppose in the same question take the same function, find out the condition for lag compensator appdi question la ketiranga appadina, just to take once again we have to change the values for a and b. Appo neenga enna பண்ணுவீங்க, priority will be given to pole. First I have to place pole will be placed first, and then we have to place the 0 such that if I find the magnitude in this case, the value of a will become greater than b, that is in case of lag compensator. So this is meant for lead and this is meant for lag compensator. Anyway, in our question, the question is find the condition for lead compensator. For lead compensator, value of b has to be greater than the value of a. So the correct answer is option A. Let us see the next one. Once again, there are two functions given. Question is which is lead compensator, which is lag compensator. Hereafter you might get the clear idea, right? Just to pause the video, try it by yourself. Definitely get the answer because that is very simple question, right? But what we know, whenever we are looking for compensator, right, the priority, right? In case of lag compensator, priority will be given to pole. In lead compensator, priority will be given to 0, right? That things we know. So once again, whenever I am looking for poles and 0 configuration of lag and lead compensator, if it is the lag compensator, then priority will be given to pole nearer origin, then priority will be given to 0, right? That is lag compensator. If I am doing the same thing for lead compensator, priority will be given to 0, that is 0 will going to be placed nearer to the origin, and then second priority will be given to pole, right? So that is the difference between lag compensator and lead compensator. Let us see. So the first one, this is going to be lag compensator and the second one is going to be lead compensator. Let's see what type of question that was given to us. Take the first one. In this first one, numerator we have 0, denominator we have pole. Once again, numerator we have 0, denominator we have pole. Here it is, that is pole, this is 0, that is 0, this is pole. That things that are we know. Let us see case number 1. S equal to minus 1, S equal to minus 2. We have two people, S equal to minus 1, S equal to minus 10 abdina. You ரெண்டு பேர்ல first யார் வருவா? 0 will fall in place. S equal to minus 1 will be placed first. That is a 0, so it will be represented by dot. And then S equal to minus 10 will be placed second, such that the first one is going to be lead compensator. That is C1 is going to be lead compensator. Let us take C2. S equal to minus 10, it is a 0, right? And then first S equal to minus 1, it is a pole. So pole will be placed first, and then we are placing 0, that is minus 10, such that second one is going to be lag compensator. So what is the correct answer for our question? For our question, lag compensator, that is C2 is going to be lag compensator, C1 is going to be lead compensator. Where is your C1? C1 is lead compensator, C2 is lag compensator. So the correct answer is option 2. Let us see the next one. Actually here, general system is given, right? In the diagram already we saw only two type of compensators. Actually one more compensator will be there, but generally we are designing first lag compensator and then lead compensator. What type of compensator it is? Of course that is lag compensator. Now anyway, question is they did not talk about anything. That is they did not talk anything about the type of compensator that we are using. Nothing they are given. Just they are given the diagram. The question is find the frequency at which phase angle offered by this system is going to be maximum. That's all, right? So frequency at which phase angle offered by the system is going to be maximum, right? Now we know the condition. Actually, anyway, this is lag compensator, we know general transfer function, everything, right? But system is given now. How do I proceed further? We know, right? How to proceed further when we have some set of physical electrical systems, right? Let me take this system. Let us proceed further from the beginning. Already I have done all those things in our general analysis itself. But for a better idea, let me proceed from the beginning. If in your exam some type of questions is given like that, then how shall we proceed further? The first thing is, see, anyway, given it is, see that here we have a capacitor, right? So that capacitor, we are proceeding with the Laplace only, no? We are in control system. So the simplest way of bringing the transfer function is Laplace only. For that, we are converting all these terms into Laplace domain. For that, capacitor Laplace is going to be 1 by Cs. I am writing it general manner and then we will reduce it, right? Let me treat this one as your resistance R1 and let me treat this one as your resistance R2, such that the overall impedance, in between this we are going to measure the output. This is our input. Now we have to write down the transfer function for this given lag compensator. How will you write? Output in Laplace, it can be written as V naught of S. Input in Laplace, it can be written as V naught of S, such that when I am looking for output V naught of S, since you see that these two components are connected in series, across this only we are going to measure the output. So the total impedance offered by the output port, right? The total impedance offered by the output port can be written as R2 plus 1 upon Cs. Yes or no? If I reduce this function, it is going to be R2 into Cs plus 1. Denominator is going to be Cs. That is the overall impedance offered by the output port. Whereas from the input, all these people are connected in series only now. So if you want to know the drop across this impedance, you can simply apply voltage division rule. So V naught of S should be equal to input voltage V naught of S into drop across this total impedance. Let me treat this net impedance with Z first for our understanding. Later I will replace it. So Z divided by total impedance is going to be Z plus R1 impedance, that is resistance R1. Later let us reduce the expression. Bring this V naught of S to the left hand side such that the overall function become V naught of S upon V naught of S can be further written as, can be simply written as Z upon Z plus R1. Let us proceed further. The value of Z1 is replaced by R2 Cs plus 1 whole divided by Cs. In the denominator, Z1 can be once again replaced by R2 Cs plus 1 whole divided by Cs plus value of R1. Let me consider here. Now take the cross product such that this net function can be further reduced to be R2 Cs plus 1 whole divided by Cs, whereas in the denominator we have R2 Cs plus 1 plus R1 Cs whole divided by is going to be Cs. See the cross product such that Cs are going to be cancelled. Let me reduce this function further. So next what I am getting R2 Cs plus 1. In the denominator we are going to get R2 Cs plus R1 Cs plus 1, right? So let us reduce this function further. What I am going to do now, anyway this function has been reduced. After reducing this function from these two things, actually I have been written, this is going to be R2 by S, sorry, this is R2, right? Now just reduce this function further. What we are going to do, R2 Cs, okay, let me keep it in the numerator plus 1. Let us go to the denominator. In the denominator, just I am taking, right, what I am going to do, I am going to take R2, that is, what shall we do, take R2C, right, Cs from these two terms, okay, let me simply reduce, just to take Cs outside. If you take Cs outside, then it will become R1 plus R2. Simply we can write, instead of going with the multiplication and division at all, let me try to reduce it simply, right? Now from this what I am going to do, just to take the numerator and the denominator, I am going to multiply by R2 and I am dividing it by R2. I am going to multiply by R2 and I am dividing it by R2. Like that, at last what we have done in our transfer function also, tau is going to be considered as R2 into S. Tau is going to be considered as R2S. So wherever we have tau, that is R2 into S. R2S, sorry. Time constant, guys, I made a small mistake. Time constant R2 into C can be considered as time constant tau, such that this R2 into C can be replaced by tau. R2 into C can be replaced by tau, and then what we are going to do, this total time can be replaced by alpha, attenuation factor alpha. So the value of attenuation factor alpha will become R1 plus R2 divided by R2. These derivations are already we have seen, such that the generalized transfer function will become tau s plus 1, denominator alpha times of tau s plus 1. Yes or no? This is the general transfer function of our lag compensator. Already we have been observed these things, whereas the value of alpha for our lag compensator is going to be greater than 1. That is amplification factor. Okay, that things are we have been concluded already. Getting back to the system. Question is, find out the value of omega at which we are going to observe maximum frequency, right? Omega value na எப்படி apply பண்ணுவோம்? One second, right? From this, let me reduce this function. Okay, we saw from the general transfer function, I told you just remember three expressions, right? First one is general expression, and then frequency at which we are observing the maximum phase angle. Frequency is what? 1 upon tau into under root of alpha, very important. Second, I told you corresponding free phase angle phi m is going to be what? Sin inverse of 1 minus alpha divided by 1 plus alpha. Anyway, in our question, the one and only question is find out the frequency in which your phase angle is going to be maximum. That's all. That is the one and only question. Now further, we have to estimate the value of tau and alpha. Let me do it. Now how to calculate the value of tau from this? See there, tau is going to be estimated as tau is equal to R2 into C. Now getting back to the question, R2 is going to be 1 ohm into the value of C also going to be 1 farad, such that is going to be 1 seconds. The value of tau is going to be 1. What about the value of alpha? Let us estimate. Alpha is equal to R1 is 9 ohm, R1 is 9 ohm plus R2 is 1 ohm divided by 1. So 9 plus 1 is going to be 10 ohm. So see that alpha is going to be 10, tau is going to be 1, such that the value of maximum frequency will become 1 upon tau is equal to 1 and alpha is 9 plus 1 root 10. Now you know how to get the value of 1 by root 10 and you can do it by yourself. So the correct answer is 1 by root 10 radian per second. That is the correct answer for our question. In the same way, if you will be tested to calculate the value of phase angle phi m கேட்டிருந்தாங்க, what shall we do? Simply take the same question. Phi m ஓட வேல்யூ வேணும் அப்படினா see we know alpha ஓட வேல்யூ நமக்கு தெரியும் இல்லையா? Alpha is equal to 10. அதை அப்படியே நீங்க சப்ஸ்டிட் பண்ணீங்க அப்படினா definitely you will get the value of maximum phase angle. So that is how we are solving the problems, right, in our lead compensator and lag compensator. Let us see the next one. Let us see the very beautiful question. Actually the question is some compensator is given, compensator function is given. The question is frequency range in which phase lead of the compensator is going to be maximum, right? அதாவது phase ஓட lead, அதாவது phase angle ஓட வேல்யூ வந்து என்ன ஆகும் அப்படினா leading phase angle, அதோட வேல்யூ வந்து maximum ஆகும், right? அது எந்த range of frequency ல வந்து phase ஓட வேல்யூ வந்து maximum ஆகும், lead compensator especially leading phase angle will become maximum, right? Leading phase angle will become maximum. Anyway, that is the given system. Frequency calculate பண்ணோம் அப்படினா don't think too much, right? We have been concluded only three type of systems. It might be lag compensator, lead compensator or lag lead compensator, right? Of course, lag lead compensator sometimes in your examination will be tested for lead lag compensator also, right? That I don't know. We have to check, right? So thing is, generally we have general systems are lag compensator, lead compensator in the sense in the numerator we have 0, in the denominator we have a pole. In case of lag lead, lag compensator அந்த numerator ஒரு person, denominator ஒரு person. Lead numerator ஒரு person, denominator ஒரு person. Lag lead or lead lag அதுல எப்படி இருக்கும்? Numerator we have 2 person, denominator also will have 2 person. That is lag lead compensators, right? Let us proceed further. I would like to draw the Bode plot for this given function to get the clear idea about this one. How will you draw the Bode plot? Very simply we can draw. For that, first I would like to place the poles. I would like to identify the type of the system, whether it is what I can say lag compensator, lead lag compensator or lag lead compensator. That I would like to identify from this. Very simple question. Don't be panic. Anyway, this question was asked for 2 mark only, but I don't think that is worth for 2 mark, right? Let us see. Just place the poles and zeros in its corresponding location. Place the poles and zeros in its corresponding location. Shall we do it? Just to take the first person. In this first person, what is the value? If I equal it to 0, then it will become s plus, or I can say simply I can say s divided by 0.1 plus 1 should be equal to 0, such that the value of s will become equal to minus 0.1. First person. Next, second 0, that is 0.1. We will find the value first. Second person will become s by 100 plus 1 should be equal to 0, such that the value of s will become equal to minus 100. Second, just to take this one, if I equal it to this one, that is pole, s plus 1 should be equal to 0, or I can say s equal to minus 1. Now take this one, if I equal it to 0, it will become s equal to minus 10. Anyway, here I have 2 poles, p1 and p2. Similarly, I have 2 zeros, z1 and z2. Let us place them in the order of ascending. Negative நம்ம எப்படி place பண்ணனும் அப்படி தெரியும், right? Negative ascending order. How will you place it? Let us see. First, in the 4 personல which person will going to lies nearer to the origin in the left of the s plane? First யார் வருவா? minus 0.1 here. Next here I have minus 100. Here I have minus 1. Here I have minus 10. Such that first person is going to be your 0. That is minus 0.1. Next person it is a 0. Next we add by the 4 பேர்ல 1 will come, 1 is a pole, right? So next minus 1 will fall in place. Next minus 10 will fall in place, and then minus 10. At last we are going to consider the effect of 0. Such that, see there, what type of system it is, did you observe? From the origin, right? So the dominant one is, first we are observing the effect of nearer to the origin if I have 0. Nearer to the origin if I have 0, then that is called lead compensator. Yes or no? Near to the origin. So this set of compensator is called lead compensator because priority was given to 0. Then it will act as a lead compensator. And then see the second cell. In the second case, first we are giving priority to pole, and then we are giving priority to the 0. Such that this system is called lag compensator. Now from the origin, if you observe the system, first we are observing the effect of lead compensator, and then we are observing the effect of lag compensator. Such that this system is called lead lag compensator. I told you now in your examination they will reverse the question. See that? That is called lead lag compensator. In practice we don't have such type of system, but in exam we will be tested. Basics should be required, right? Anyway, the question is lead lag compensator. Now the question is, find the range of the frequency. From here itself I will define, but to get the better idea, let me extend our discussion. Anyway, we are going to draw lead lag compensator, right? Shall we draw the body plot for this? Very simple, right? Quickly I will draw. You know how to draw the body plot, right? Body plot is, of course, it is log omega only, but on the paper we are going to omega, right? Versus magnitude in dB. Anyway, nothing, I am not going to do anything here. Just we are going to start. See that in our system, first we are going to body plot are able to see that in the order la applying body plot for our lead compensator into the system at the s equal to 0.1 or omega equal to 0.1. Magnitude, now you have to consider the magnitude, don't consider the sign at all. Magnitude of the 0 is going to be 0.1, magnitude of this one is going to be 1, right? In omega now by drawing the body plot, s will be replaced by j omega, and then we are calculating the magnitude of the system such that s j omega atom will gone. Just we are going to consider the frequency of the system. So here frequency, first 0 frequency will be falling in place, 0 frequency, that is 0.1, and then we are considering 4, that value is 1, and then we are going to consider 10, and then we are going to consider 100. So let us see from the origin. Suppose initially your slope will have some value, right? Slope will have some value. Initial value are not known. Just draw the plot, that is sufficient. Next, initially we are not having any poles or zeros at the origin. Origin the poles and the zeros varla initial slope does not be present. Next, what will happen? Exactly at omega equal to 0.1, we are introducing a 0. 0 and now always 0 will provide plus 20 dB increment in our system, in our slope, right? Such that initially we have 0 dB and then will be shifted to plus 20 dB. It will be shifted to plus 20 dB. Next, what will happen? Slope will become plus 20 dB. Exactly after a certain duration, we are going to add. What we are going to add? We are introducing the pole. We are introducing the pole. Pole and it will provide minus 20 degree phase shift such that it will be drooped now. It will be drooped. So initially 0 and then plus 20. Again we are adding minus 20 at omega equal to 1. Next, what will happen? Again at omega equal to 10, we are adding one more pole. Pole will droop. One more minus 20 degree will provide. Next, what will happen? Exactly at omega equal to 10, we are giving this one. Next, after a certain time period, once again one more 0 will be added. See there, 0. We are introducing first one 0 introduce plus 20. Because of the pole, again it will become 0. Plus 20 minus 20. Again one more minus 20. Again we are adding plus 20. Such that we are getting back to same slope. So here I am introducing 0. Now see there, initially my system is acting as a lead compensator. In which zone? This is the zone my system is going to act as a lead compensator. See there, in this zone, let me break it into 2 off, right? Let me break it into 2 off. In this zone, my system is going to act as a lead compensator. In this zone, our system is going to act as a lag compensator. In lead compensator, the range of the frequency is, for our lead compensator, range of the frequency is 0.1 to 1 radian per second. Right, that is for lead compensator. Whereas for lag compensator, range of the frequency, let me define just to see the observation. First here we have lead compensator, and then the slope will become 0 once again, and again we are creating the lag compensator effect. So from 10 to 100, my system is producing the effect of, that is we are releasing, right, or we are observing the properties of lag compensator. This is the range of lead compensator, whereas second range is going to be for lag compensator. Anyway, let us getting back to the question. The question is frequency range in which phase lead compensator is going to be maximum. face lead compensator. Where is our lead compensator? This is the lead compensator. அப்ப இந்த ரெண்டு பாயிண்ட்க்கு நடுவுல தான் your phase angle will going to be maximum for lead compensator. You can draw the waveform. இதுக்கு நீங்க phase angle வரையீங்கன்னா you get the waveform. You know how to draw. Phase angle எப்படி வரைவீங்க? First we are initially 0 at omega equal to 0 1 we are introducing a 0, right? Initially 0 degree. First 0 introduce பண்றீங்க அப்ப 90 டிகிரிக்கு ஷிஃப்ட் ஆகும். அதுக்கு அப்புறம் திரும்ப 0 introduce பண்றீங்க. போல் introduce பண்றீங்க 0 டிகிரிக்கு வந்துரும். அதுக்கு அப்புறம் திரும்ப at omega equal to 10 one more அடுத்து என்ன பண்ணிருக்கோம் 10 ல we are introducing one more pole அப்ப -90 டிகிரி போகும். அதுக்கு அப்புறம் திரும்ப என்ன ஆகும் at 100 degree 100 we are introducing one more 0 such that it is getting back to 0. See that maximum phase speed அப்ப எங்க நடக்குது பாருங்க 0.1 க்கும் 1 க்கும் நடுவுல தான் we are getting leading phase angle. Lagging phase will happen in between 10 and 100. So the correct answer for our question is 0.1 to 1 we have leading phase angle. We are reaching maximum phase lead, right? So 0.1 to 1 is option, yes, this is going to be lead. Suppose in the question if you will be for lagging கேட்டிருந்தாங்க அப்படினா this case will be 10 to 100. எங்க இருக்கு பாருங்க 10 to 100. This is for leading. For our question that is the answer. Suppose lagging கேட்டிருந்தாங்க அப்படினா this is the correct answer for our question. See, that is how we are facing the various questions in our compensators and controllers. I already been told you in compensators and controllers your questions are very easy. Just by looking at the question itself you can predict the answer, right? So this is all about compensators. In the next lecture we are going to start almost the last chapter of our control system. Apart from that we have a small friction about the mathematical modeling. That things we will discuss at last. Okay, so let us wind up with this. Thank you all.